Okay, welcome back. The following is a video about a problem that we did in class, and this involves using the fundamental theorem of calculus. Okay, so let me kind of introduce this graph and show you what we need to do in part A. What we have is we have the graph of the function f is shown above. So this is a graph of f, okay? And then it defines a function g that is an integral defined function. So g of x is equal to the integral from 0 to x of f of t dt. So what we have learned using the fundamental theorem of calculus is that if I have a function g of x that is an integral defined function, integral from 0 to x of f of t dt, then what I know is that my input into my function is the upper bound of my integral, okay? And we did that in previous examples. But what we know about the fundamental theorem is that if I take the derivative of this integral function, then it simply just gives me the integrand in terms of x. So really here, my function g, if I take the derivative of that, I just get the function f, okay? And so that's what this graph here is. This is a graph of f. So I could also say that not only is this a graph of f, but this is also a graph of g prime of x, okay? Now, the other thing I can say is that if I wanted to find g double prime of x, my second derivative, well, then that's just the derivative of x, of f, okay? So now down here in part A, it wants me to calculate these three different values, g of 4, g prime of 4, and g double prime of 4. So let me first do g of 4. So if I do g of 4, then that means that I'm going to take the integral between 0 and 4. 4 is where I plug my value in for x, okay? So I plugged it in here, of f of t dt, okay? So I want to calculate this area between 0 and 4, okay? And so if I find the area here, this is the area of the triangle, a 2 by 1 triangle, the area is equal to -1. It's below the x-axis. This triangle right here has an area of 1. Okay, this triangle here also has an area of 1. And this rectangle here, a 1 by 2 rectangle, has an area of 2. Now these two areas here, this area under the curve and this area under the curve, these two areas, because they're the same area, they cancel each other out. So really, I'm just calculating the area here, which is an area of 3. So what we know is that g of 4 is equal to 3, and that's my answer. Okay, so if you wanted to write g of 4 is equal to 3, you can do that there. Okay. Then I want to find g prime of 4. Now, what I know is that g prime of x is the same thing as f of x. So if I'm asking for g prime of 4, well, then I'm really just asking for f of 4, which is the y value when x is 4. So when x is 4, my y value ends up being 0. Okay, so that's the value for that. The other thing I wanted to find is g double prime of 4. Okay, well, that's the same thing as me saying f prime of 4. And so if I wanted to find the slope of this line, to get from here to here, I go down 2 over 1. It's going from the top right to the bottom, no, top left to the bottom right. So we get a slope of -2. Okay, so this was the area under the curve between 0 and 4. This is the y value when x is 4. And then this is the slope when x is 4. So I get all that just by writing this, okay? Without writing this, this would be a very difficult thing to achieve, okay? Now, let's move on to part B. Part B asks the question, given the same scenario, does g, this function g, have a relative minimum, a relative maximum, or neither at x equals 1? And we need to justify that. So what I want to do, I first want to write out, make sure we have that stuff written down, that if I have g of x is equal to the integral from 0 to x of f of t dt, then I know that g prime of x is equal to f of x. And I know that g double prime of x is equal to f prime of x. Okay, anytime I have a function like this, I want to take its derivatives and write them out. Okay, so not only is this a graph of f, but this is also a graph of g prime as well. So it wants to know, does g have a relative minimum or maximum at x equals 1? Well, here's 1. Okay, and this is really a graph of g prime, meaning I can do the first derivative test and answer this question. Okay, so what I know at 1, okay, g prime of 1 is equal to 0. So g prime of 1 equals 0. So that means we're going to have some sort of extreme value here. But what we see is that my first derivative changes from negative to positive. So because of that, I know that g is decreasing and then switches to increasing. So I end up having a minimum here. Okay, and so let's write that. Okay, at x equals 1, g has a relative minimum because g prime changes from negative to positive. Okay, because g prime changes values from negative to positive, I know I have a relative minimum. Okay, but that's kind of hard because you're given a graph of f, but if you rewrite all this, you know that really f is just the same thing as g prime. Okay, now the last part's kind of tricky. Okay, it gives me this scenario. Suppose that f, this function f, which is really g prime, let's write all that out again. So g of x equals the integral between 0 and x of f of t dt. I know that then g prime of x is equal to f of x, and I know that g double prime of x is equal to f prime of x. So it says, suppose that f, this function f, which is really just g prime, is defined for all real numbers x and is periodic with a period of length 5. Periodic means that it repeats, okay? Like trigonometric functions are periodic because they just keep repeating. So what you end up getting here is you end up getting this same graph that just keeps repeating, okay, over and over again. And so this would be like an x value of 10 right here, and it's just going to keep going and going and going, okay? So it says the graph above shows 2 periods of f. Now it tells me that g of 5 is equal to 2. All right, so that means that the area under the curve between 0 and 5 of f of t dt is equal to 2. Okay, now I do agree with that because if I look at the areas between 0 and 5, I see that this area has an area of -1, this area is 1. If I add those together, I get 0. Same thing here. This is 1, this is -1, so I add those together, I get 0. You're only left with 2. Okay? So now it wants us to calculate, well, what's g of 10? Well, g of 10 is the integral between 0 and 10 of f of t dt. All right, so if I go from 0 to 5, I get an area of 2. If I do the same thing from 0 to 10, I'm going to get 2 of these. Well, this had an area of 2. This has an area of 2. So my total area here for g of 10 is going to be equal to 4. Okay? Now, the last part says, write the equation of a tangent line, all right, to the graph of g at x equals 108. So if I need that, if I have that, then I need to do this. I need to do, I need a point, and I need a slope. Okay, my point, I have an x value of 108. I need to find a y value at 108 of g, okay? So I'm going to find g of 108. And then I need a slope of at x equals 108. So I'm going to write g prime of 108, okay? Which is really just f of 108. All right, that's a 108. So now what we can do here is we can kind of rewrite this. Now, because this is periodic, this repeats every 5 units. It repeats. So what I can do is I could actually come over here and I could say, all right, well, I'm going to call this 105. I'm going to call this 106. I'm going to call this 107. I'm going to call this 108. So if I were to extend this graph out and think of x values that are really big, like 105, 106, 107, 108, it's still going to have this same shape. So what I want to think about is I want to find g of 108. Now that is the integral between 0 and 108 of f of t dt. Now what I notice is that for every 5 of these, okay, I have an area of 2. And I need to try and think, okay, well, how many of these periods would I have if I had a length of 100? Okay, and I would end up having 20 of them. And 20 of them, I would multiply each of those areas by 2, and then I would have an extra one for 105, so I would add another 2. And then I would end up having to add another one, because I want to find up to 108, which is the same thing as going up to 3. This has an area of -1, this has an area of 1, so those cancel out, and I have another area of 2, so I'm going to add an extra 2 to that. So I end up getting 40 plus 2 plus 2, which ends up giving me 44. So I end up getting a y value here of 44. Now my question is what is my slope? What's g prime at 108? Okay, so that really is the same thing as me asking, well, what's g prime of 3? And the y value there is 2, so 2. So I have a slope of 2. Okay, so now I can write my equation, and I can write y minus 44, because that was my y value, is equal to my slope 2 times x minus the x value of 108. Okay, this is a pretty tricky problem. Now, it's nothing that you've never done before. It's just that a lot of this stuff is just written very differently. Okay, so you kind of just got to get past that. All right. That's it for this question. Thank you.